Hey guys, so I'm going to talk through this just a little bit with you for section 3.6. This is what the no calculator part of the test is going to look like. So this is really important that you guys go through all of the steps and try this. So I want you to listen for a few minutes and I want you to pause the video when you need to and write some stuff down. To find the y-intercept of the function, the y-intercept is always the constant because the x value is 0. So when I plug 0 in here, 0, 0, 0, 3. So I get 0, 3. So when it asks for the y-intercept, that's where you plug in a 0 and you get out a 3, which means you're always going to get whatever the constant is right here, just exactly like we did in standard form with the quadratics. So I went ahead and went over here and put 3 on my graph. Right, end behavior, we know this guy is odd and positive, so it's going to go up on the right and down on the left. So I put those arrows right there just to show that I could tell what my end behavior was going to do. You need to be able to write this out on the test. So as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to negative infinity. You have to be able to write this out on this page on the no calculator part of the Unit 3 test. This is all the possible rational zeros. This is what we did in 3.5, just listing out all the P's and Q's. Now it says factor completely, given a 0. So in section 3.5, we put this in the calculator to find a 0. And this is the no calculator part, so I have to give you one. So you don't have to type it in. I give you that when x is 1, y is 0. So that means that 1 is one of your roots. Okay, so you're going to do synthetic division with a 1, bring down the 2, multiply and add, and then you get it broke down into a quadratic. This quadratic factors using the AC method. And then when we go to factor completely, you have to write down all of it. You have to write down every factor, the x minus 1, the what you get from factoring, the x plus 3, the common factor that comes out, and the 2x minus 1 left over. So this is what we're looking for when it says factor completely, all the factors. Then find all the zeros. So then it wants you to take each one of those factors and solve them for x. No problem. Then to write the x-intercepts, we're going to write those zeros as actual x-intercepts. So as points of x comma y, the y being a 0. Okay, then I went ahead and put those on my graph. Okay, so I can graph my zeros, 1, 1, negative 3, and a half. Okay, I've got them all on there. Then the other thing that we did in the calculator was the max and min. And so I also have to give you those if I'm not going to give you a calculator. So the negative 1.8, which is about right here, just over negative 1, and 15.5. So I just went up here and guesstimated about where it would be because this is 10. So negative 1.8 and 15.5 is up here. And then 0.8 and negative 0.5 is between my zeros right down here. So knowing the zeros, the y-intercept, and the max and min, and how my end behavior was supposed to go, I went ahead and sketched the graph. And then domain and range, I know for this guy is negative infinity to positive infinity, both directions, because it keeps going both ways. And then for increasing and decreasing intervals, this is just like we did back in section 3.2. From negative infinity to this x. Oh, and it gives you a hint. It says over what intervals of x is the function increasing and decreasing. So from negative infinity to this turning point, which is at negative 1.8. See, I circled my x's here. I'm increasing, and then between the two turning points, I'm decreasing, and then from 0.8 to positive infinity, I'm increasing again. All right, so for this next example, it's really similar. The y-intercept is the constant because the x's would all go to zeros. And then my end behavior, this guy's odd negative, so I'm up on the left and down on the right. Okay, so I write out my end behaviors. I find my P's and Q's. Okay, what are all the possible zeros? They're all over 1, so I just didn't rewrite them. I just boxed in all of the constant because they're all over 1. Completely factor, so I'm given that the root is negative 2. So then I break it down, and I get it broke down into negative x squared plus 9x minus 20. I took out the negative 1 so I could shortcut factor. And then when we write all of our factors, we need to be sure and include the factor that gives me the negative 2. Then find all the zeros by setting them equal to 0. write the x-intercepts, it gives me the extrema of the max and min. So I went ahead and graphed those. There's my maximum and there's my minimum. And I had to do my y axis by fives because I needed to get negative 40 and negative 40.1. So I did my y axis by fives, but I didn't do my x axis by fives, just my y. So that's why these points look like they do. And then domain and range, again, is negative infinity to positive infinity. And then for increasing and decreasing intervals, I have my orange sections broke out here for that. So then you can find your increasing and decreasing intervals. All right, for this back page, this is just, well, you can read through these first couple. They're pretty self-explanatory. But on this last part, this is really important. You do have to be able to do this on the test. And it's wanting you to actually write the polynomial function with the zeros. So if the zeros are 3, 0, and negative 2, what were the factors that gave you that? Well, to get the 0, we needed an x. To get the 3, I need an x minus 3. And to get the negative 2, I needed x plus 2. So then I FOIL these two out, and then I multiply the x back through. Okay, because this is intercept form. It says show the function in intercept form and standard form. This is intercept form right here, just like it was with the quadratics, but to get it in standard form, we have to multiply it all back out. So this one's pretty easy, but things that we need to think about, if it tells you something has a multiplicity, so like here it says 1 has a multiplicity of 2. So when you go to write the factor x minus 1, that means that happens twice. So when you go to multiply it out, you need to have it twice. And then I and negative I. So your factors for those are x plus I and x minus I. It's actually the opposite ones. The negative I you get from right here. The positive I you get from right here. But when you go to multiply stuff back out, you absolutely want to multiply your stuff together that has the i's. Because as we remember from last unit, I squared equals negative 1. So if you do that, then your I squareds are going to go away, completely go away, and you're left with just x squared plus 1 because these guys are conjugates. Okay. So this one was a little bit more intense to multiply out. On number 7, I want you to make a correction. 7 and 9, I want you to make a correction on those. And so number 7, if the zeros are 5 and 3i, well, imaginary numbers come in pairs. They have to. We never just get one imaginary number. So if there's a 3i, there also has to be a negative 3i. So if there's, to get the 5, I need x minus 5. To get the positive 3i, I need the negative 3i, but then there also has to be a positive 3i. When you multiply this out, multiply these two together first. This one has 5 zeros, so this is going to end up x to the 5th. This is just a lot of algebra, multiplying this all back together. Number 9, I wanted you to get rid of this binomial right here and just change it to 2i, which means there also has to be a negative 2i. So this 3 gives me x minus 3. This 2 gives me x plus 2. And then this is x minus 2i and x plus 2i. Then again, just a lot of algebra. And I would absolutely multiply your stuff together that has the i's in it because the i's completely go away, which is awesome. They're conjugates. And we know that multiplying an I by its conjugate makes the i's go away. And then same thing here. I've got 4i with a multiplicity of 2. So if I have 4i, I have to have negative 4i, which means they both have a multiplicity of 2. And then I would just multiply the conjugates together because then the i's go away. All right. Work on this, take some notes down, and then get the homework practice.